we'll get to here in a second. But then, yes, we will also go back into the capsule so that we can show you where the ZGI is now. But the ZGI was chosen by the crew after a contest where the crew asked for submissions. They got submissions from around the world to, again, design their ZGI that is going with them to the moon.
It's kind of like any other road trip. You need clothes, food, a map, your favorite toy. Really. Except this toy has a job to do up there because this is a zero-gravity indicator. While not a scientific instrument, this safe and soft object tells the strapped-in astronauts that they've reached weightlessness. For Artemis II, the crew wanted a one-of-a-kind ZGI, so we asked you to come up with it.
Thanks everyone for sending in your entries from around the world. Over 2,600 of you submitted.
And we loved seeing all of your contributions. It was a really difficult decision because each design had a unique quality that stood out to our crew.
In the end, we were able to narrow it down to a top 5 from Finland, Canada, Peru, and 2 from the United States, Kansas and California.
In the end, we went with one called Rise. It was a design inspired by the Earthrise photo taken on Apollo 8, which is very special to our crew.
With the winner chosen, next came the task of bringing it to life here in the Thermal Blanket Lab at NASA's Goddard Space Flight Center. This lab specializes in custom materials to protect sensitive spacecraft equipment and is perfect for creating a ZGI that meets the rigorous safety standards of NASA.
Because you have to be concerned with whether the thread's going to outgas or if it will hold up, if it's flame retardant.
This is the Rise ZGI doll. All I have left to do is to close the opening here and hand sew the hat on, make sure its stuffing is stuffed in there, and we have our pocket here for the SD card.
And on that tiny SD card will be millions of names submitted to virtually join the crew aboard Orion.
Got Rise. Not the real one, obviously, but this is a replica. I mean, so clever for Lucas and his family to design.
Yeah, I love that he replicated the famous picture that we all love of Earthrise, and then I love that the bill represents the space in between the moon and Earth. It's just such a cute and wonderful way to represent this mission.
Yeah, and again, Earthrise, very important to this crew. It harkens back to the picture that was taken by the Apollo 8 crew where they saw Earthrise, and so very appropriate since, again, now here we are going to see Earthrise again with this mission.
Yep.
So yeah, so this is little Rise here. And then you heard in that video that there is an SD card that is zipped inside with the real ZGI with the crew. So get this, more than 5 million people submitted their names as part of NASA's Send Your Name to Space campaign. And actually, Christina said that her niece and nephew's names are inside that SD card.
How cool is that? Her nieces and nephews are going to go with her.
Yeah. Love this. Love that people are engaging in such a cool way. And actually, if we take a look back inside of Orion, we can actually see the take a look back inside of Orion, we can actually see the actual ZGI inside with the crew. As we said, the purpose of a zero gravity indicator is to show when we've reached the weightlessness of space. Now, I know that it's probably dark in there because, as we said, the crew decided to just dim it a little bit for them. But here again, as we see, Reed on your left, Victor on your right. Below Victor, or next to Victor, again, because they're on their back, it's a little weird. It's a little hard to explain their orientation. But between basically Victor and Christina is where Jenny Gibbons has placed the zero gravity indicator. And Jenny, who, again, Nicole just brought up, Jenny is one of the backup crew members. So we mentioned how Andre is the backup crew member for the NASA astronauts. Jenny is the backup crew member for Jeremy.
Yeah, Jenny's one of our Canadian astronauts, and yeah, so she's been also helping with preparations for today and helping get the white room ready, get the capsule ready, and she's actually going to be a Capcom for Artemis II as well.
Yeah, she's from Calgary, Alberta, completed astronaut training in 2020. mechanical engineer, combustion scientist, and actually before becoming an astronaut, she was an assistant professor. So again, another very well-accomplished person on the team. And I know the Artemis II crew has really enjoyed working alongside both Andre and Jenny.
Yeah, actually, Jenny was our EBQ mentor when I went through our ASCANner initial training, so she helped us with all of our spacewalk training, which was kind of cool as well.
Okay, and there we have Andre again, number 2, with the rest of the closeout crew team there. Why don't we get another check with Daryl and see how the launch countdown is going.
Still going quite smoothly here from firing room 1 here at the Kennedy Space Center. Launch team working no major constraints to launch, which is great news. We did get an update on a weather balloon that the launch weather officer and his team released. This is an important weather balloon released right around the 3-hour mark. And what it told us is that winds are around 10 to 11 knots in the upper parts of the atmosphere. That's important information for the launch abort system should the astronauts need the LAS. This would, of course, pull the Orion spacecraft off the top of the rocket in case there were an emergency, and then take them offshore to a water landing in the Atlantic Ocean. And so the winds are pushing onshore. And because they're pushing onshore, the launch weather officer is keeping a close eye on the strength of those winds, because if the Orion were to come off the top, and it's powered by 3 rocket motors which can propel it or pull it especially fast off the top of the rocket, it would go up into the air thousands of feet and then splash down in the water. And if you've got wind pushing against it, you don't want that spacecraft to come back and land on land. So they're watching that very closely because of the onshore flow. That onshore flow is also what's giving us a little weather action down to the south of us along what's called the beach line, 528. We got a whole lot of people out there. We're getting ready to watch the Artemis II historic launch. Well, they just got a good soaking. Line of rain showers, I should say, passed through that area and soaked the place. Certainly rain is a possibility, spotty showers from time to time, but overall the launch weather officer tells us that we are trending towards getting that stuff to all push to the west the closer we get to our launch window. A reminder, that window is from 6:24 p.m. to 8:24 p.m. Eastern Time. We don't have a specific T0 at this moment. There's a lot that needs to be calculated before we get there. We also need to get through the rest of the countdown on time. As of right now, we are right on time. The launch countdown is going exactly as planned. That's not something that we saw certainly in Artemis 1. There was a lot of flexing in the timeline during those 3 launch attempts back in 2022. But so far today, on our first launch attempt, we're really enjoying some really solid countdown work, some solid operations by the launch team so far. And to quote our friend Lucas, who created Earthrise, we all really like that. We'll send it back to the host desk.
Thanks so much, Daryl. Yes, we really like that, and we really like Rise and Lucas. So thank you for that. That was really cute. Okay, so again, here we are in the big box here. We have our full view of the rocket, looking glorious on there with, again, some clouds, but still weather is good for launch today. And then we have the closeout team continuing to do work in the White Room. We got confirmation that they have successfully completed pressurizing the counterbalance pressurization. Basically, as Daryl explained it before, the side hatch for the crew module is very heavy. So in order to open it, there needs to be pressure applied to it, and that's what we just completed, right?
Right, that's exactly it. So the CBA, that counterbalance assembly that we're talking about, has to be pressurized. It's a pneumatic system to help. So in the case of an egress, Christina's the one that has to open that hatch. So once she gets it unlatched and unlocked, then that pneumatic system will help move the hatch. It weighs a lot, and so the average human cannot open that hatch by themselves. And so that's why we want to make sure that the system is pressurized, that it's not going to leak, and that it is ready to go in case they need to open the hatch.
So that is complete, and now what is happening are the seal leak checks. So that is in progress. Again, 2 seals go through the entirety of the hatch, and we will take the seals to pressure, hold it for about a minute, and just make sure that it is holding pressure. Again, we want to make sure that the crew has a safe, pressurized environment in any sort of situation while they're in Orion.
Yep, that's right. So we're going to take a look at it. We're going to take a look at the starting pressure, and then after a certain amount of time, we'll take a look at the ending pressure, and then there are certain tolerances that we will accept for flight.
2 hours, 37 minutes and counting from the opening of our 2-hour launch window today at 6:24 p.m. Eastern Time. After liftoff, it takes less than 10 minutes to reach Earth's orbit. Let's learn more about today's ascent profile with Gary in Mission Control.
Hey, Megan. We are monitoring here in Mission Control Houston. Flight controllers are looking at data from integrity and the Space Launch System during the countdown. We're looking at some of the events happening in the White Room now and just making sure that all criteria is met to commit to launch and ascent today. It's the team you see in this room that would be looking after ascent, which is a very dynamic phase of flight. And after solid rocket booster ignition of the Space Launch System, it's this team that takes over control of the mission. There are voices you'll hear upon ascent, calls being relayed between Stan Love, the Capcom you see here in this shot in Mission Control Houston, that's the voice from this room, and the Artemis II crew on a communications channel aptly named Orion to Earth. Here are the calls you may hear during this part of the mission. Capcom Stan Love, his first call after responding to the crew's successful roll pitch maneuver at 30 seconds is AMT high. This notes that should we lose just one of the main engines, an alternate mission in low Earth orbit can still be achieved. At 1 minute 25 seconds, you'll hear max Q on PDL. This notes that reaching the moment of maximum dynamic pressure on the spacecraft. This event happens to be in line with a communication switch to another ground station, the Ponce de Leon Inlet Tracking Annex, located about 35 miles north of Kennedy. At 2 minutes 45 seconds, you'll hear SM primed upper stage RCS ready. This means that the European Service Module propulsion system that's prepared for the next phase of aborts after the launch abort system jettisons, and the reaction control thrusters on the inner rim cryogenic propulsion stage that enable pointing and maneuvering are ready. At 3 minutes 50 seconds, you'll hear voice check on TDRS at the Kármán line. At this point, the launch abort system has jettisoned and revealed the Orion capsule underneath. This check verifies that the now exposed Orion antennas have a good signal over the tracking and data relay tracking and data relay satellites, which is part of a geosynchronous satellite network and the same assets that are used aboard the International Space Station. This communication switch happens to be at the Kármán line, a widely recognized boundary about 62 miles, statute miles, or 100 kilometers above the Earth's surface, where the air is too thin for conventional aircraft to fly and marks the point where our astronauts leave Earth and enter space. At 5 minutes 16 seconds, you'll hear the call 3-engine press. This notes that if one of the 4 main engines on the SLS core stage were to fail, 3 engines can carry the crew to a nominal main engine cutoff and proceed with the expected mission timeline. This is an important call that gives more assurance of continuing today's moon mission. At 7 minutes, you'll hear expect nominal shutdown. You'll hear this call should the main engine performance be as expected up to this point. Shutdown plans can vary and may impact G-forces experienced by the crew or future burn plans, but a nominal shutdown is more indicative of continuing the mission on the expected timeline. At 7 minutes 30 seconds, you'll hear AOA open. This notes crossing into a new abort profile. At this point, an abort would use Orion engines to escape the core stage, and the altitude and velocity are enough to make it one lap around the Earth and aim for a splashdown in the Pacific Ocean instead of the Atlantic. And then, of course, shortly after 8 minutes, you'll hear nominal MECO. You won't hear MECO right away. Teams here wait until the core stage has separated and the trajectory is confirmed as expected before that call to the crew. Now, this ascent profile is approximate, as there may be calls that move a few seconds depending on the trajectory, and of course these are the calls and times for a nominal trajectory. Teams in this room have been training extensively to prepare for any and all scenarios, and they are confident and ready to take this crew into space today. In today's pre-brief, the flight director, Judd Freeling, expressed his confidence to the team, citing the hundreds of simulations to prepare for this very moment. These are the calls you'll hear during ascent less than 3 hours from now, but now we'll turn our attention to the countdown to launch and send it back to you, Megan, at the Space Coast.
Thanks so much, Gary. Now, one of today's 4 astronauts, of course, Canadian Space Agency astronaut Jeremy Hansen. Let's go now to Jasmine with her next guest.
Thanks so much, Megan. Yeah, we're joining you live now from the Operations Support Building here at Kennedy, where crowds are starting to gather, and we're honored to have Lisa Campbell of the Canadian Space Agency joining us. Lisa, Jeremy Hansen is about to make history as the first Canadian to venture to the moon. What does that milestone mean for your agency?
Thanks so much, Jasmine. It's wonderful to be here. It's such a special moment, both for our astronaut colleague Jeremy Hansen, but also for Canada. We're here because of decades of public investment in space robotics, in space collaboration, and so for our country, we're very proud. He's so ready. He's been waiting for this his whole life, preparing, training, and he's a wonderful example of Canada.
Yeah, and that's a perfect way to capture Jeremy. He really has been prepping for this his whole life. This will be his first space flight. So what has it been like watching him become part of this Artemis II crew?
Well, as I mentioned to you, I've known Jeremy since 2020, and he's a colonel, a fighter pilot, a father, and he really is a very dedicated, passionate human being. So both for him to realize this goal of being an astronaut and flying, he also is hopeful that witnessing that will raise awareness about the value of a space program, of the benefits here on Earth, of exploring the universe and our place in it.
Wow, that's beautifully said. And really, this international collaboration has been going on for quite some time now. We've worked together in low Earth orbit and now going into deep space together. So why is it so important that we have these international partnerships?
It makes us stronger. We can go faster and further together. Canada is one of the original signatories of the Artemis Accords, and Canada and the United States have been partnered for more than 60 years in space.
Wow, that is phenomenal, Lisa. And this really is a team effort in many ways. We also have Jenny Gibbons.
Yes.
She'll be listening in on Capcom. What is her role going to be like?
So Dr. Jenny Gibbons has been training all along as the Canadian backup with the Prime crew. Last night, she was in the Orion capsule checking out all of the communications, making sure all of the systems test out and work perfectly. And then she will be among the first lunar Capcom, helping the astronauts navigate during their mission.
Wow, Lisa, that is so exciting. Any final words for the nation of Canada before today's mission?
Just, we are so proud, so excited, and we can't wait to welcome Jeremy home.
Fantastic. Lisa Campbell, thank you so much for being here today.
Thank you, Jasmine.
Of course. And with that, let's get back to NASA's Megan Cruz.
And right now,
go ahead. Ma'am, CBA press has been completed. Did you see any drop in pressure?
And MS1, we saw just a little bit. It is just over 2,600 now.
Copy. Thank you, ma'am.
again, a call out to mission specialist Christina Cook. Again, it was her responsibility to monitor the pressure on the counterbalance system that will help open the side hatch. And she did report a drop in pressure, but it seems like it's within nominal limits.
Right. They might have had a small drop, but we have a starting pressure and an ending pressure, and as long as the difference isn't too high, then we will take that. And the engineers know exactly what they're looking for in terms of that delta pressure.
And so again, that milestone on the checklist of things that have to happen before they launch today, that is complete. The crew, again, still inside comfortably as the closeout crew team work to close the side hatch. Again, a separate seal leak check, followed by a full cabin leak check, and then they will close the last abort system hatch.
Lots to do still in the White Room and marching down the countdown timeline well.
And so Bill, again, number 3 there, he is holding a silver flex hose. That hose is what will be connected to Orion in order to do that cabin leak check. So again, it does seem like we continue to march down through the milestones in this countdown. Hopefully lifting off today within our 2-hour launch window that opens at 6:24 p.m. Now, right now, people inside the Kennedy Space Center Visitors Complex are learning about this mission. There are great exhibits there about the rocket and Orion, and of course, our Megan Carter with the moon board.
All right, Megan and Nicole, yeah, you mentioned that checklist before launch. That checklist is going to continue during the mission as well, as there are several vital objectives that we are hoping to accomplish with this mission. So we've talked about the rocket. We've talked a little bit about Orion. Obviously, during Artemis I, we had that test flight, and there were no humans on board. That is our one big difference for this one, and we are going to have that crew this time. So what are they going to be up to during this mission? Let me tell you just a little bit. Now, for Artemis I, like I mentioned, we were really focused on the SLS, making sure it had the power and capabilities that we needed. We were also checking out the Orion spacecraft in deep space environments, making sure that it was good to go. Now for Artemis II, we are going to be taking the testing for Orion to the next level by adding that human component. So those test objectives are going to start even before launch. Like you mentioned, they are out there making their way through that checklist. But these objectives are going to start now, and that includes safety. So one really great example of safety is going to be something called the egress baskets. They're out there in the spacecraft, obviously, and should a situation happen to come up, they are going to have something called the egress baskets they can get in, and those are going to zip line them essentially down to the ground within seconds to safety. Another great example of those safety procedures are going to be the LAS, or the Launch Abort System that I mentioned earlier. Just a reminder, that's the one that can pull the crew and capsule away from any danger within a few minutes of into the launch. Now, those are just a couple quick examples, but our recovery teams have been training extensively, quite a lot, to make sure that they are ready and prepared for any challenging situation that could possibly arise. All right. Several other objectives that we are going to be looking at are also going to be communication checkouts. That is going to be vital. I know we talked a little bit earlier about all the maneuvering that they're going to be able to do, but we want to make sure that they have full communication ability from space to ground so that we can fully support them here. We are also going to be checking out those life support systems. Obviously, we've talked a lot about the service module and what it is going to do for the crew, but we want to make sure that those life support systems are fully functioning, obviously, before we send them farther into deep space. That's going to be critical for them. So on top of being able to maneuver the spacecraft and check everything out, we are also going to be making sure that everything is fully functioning. So as you can see, big part of this mission is to make sure that the spacecraft, the hardware, and all the operations are working, and that the data is going to make sense. And speaking of recovery, we are also going to have the opportunity at Splashdown to recover that launch or that flight data, and we're going to be able to take that back, analyze it, and make sure there are if there are any enhancements we need or changes we need to make before our next missions, we'll be able to do so. So lots to do. They're going to stay very busy, obviously. And with that, I will turn it back over to you, Megan.
2 hours, 25 minutes and counting, and the crowd, check it out, continues to grow at our Banana Creek viewing location. They will have a great view of launch, and we will go back now to Leah Martin, who's standing with her next guests.
Hey, Megan, yeah, we're surrounded by thousands of people, some here local from the Space Coast, but we actually have quite a few people who have traveled a pretty far distance to be with us today. I'm actually joined here by a group from the International Space Station Ambassadors Program who have come from all over the globe. Saku, you're here from Japan, you've come now from Mexico, and then we have brother and sister Cosma and Jesco here who are visiting from Germany. You actually told me that you participated in the NASA Rover Challenge in Huntsville. How was that experience, and how is it kind of participating there in Alabama and then being here today?
So it is an amazing experience because you meet so many young people with visions, with dreams, with ideas which inspire you and motivate you. And it's even better to be here now to see the SLS launch because we are going back to the moon, and that's what we're working for.
Absolutely. And, you know, the Artemis missions, we talked a lot about the Artemis Accords and this being an international effort. You were actually telling me, Saku, that you're interested in becoming an astronaut with JAXA, pursuing your PhD to be able to do that. Tell me a little bit about that.
Yes, actually, I applied for the Japanese Aerospace Agency, the astronaut selection like 2 years ago, and then I didn't make it all the way, but I'm still working on it, and hopefully I can be at the launch pad sometime, and then I hope to go back to the moon and Mars, and yeah, I'm working on it.
Absolutely incredible. And Val, you're from Mexico. We were talking a little bit about women in space. This is a team who, you know, is predominantly made up of women. What is it like knowing that Christina is on that rocket right now, about to be the first woman to travel around the moon?
I think that's such an amazing news. It's just so inspiring that we are taking the first black person and also the first woman to the moon. It's just the first step in humanity and a big step in equality as well.
Megan, a lot of excitement here, not just in Florida, but from around the globe, and we're keeping our eye on that rocket, and we're ready to see it lift off.
Thanks, Leah. Yeah, a lot of excitement, but also a lot of inspiration. Again, this is part of, or a big part of the reason why.
130.6.
Good readback. Aux 1 voltage, 131.3.
I copy 131.3.
Again, those numbers you hear, they're referring to specific steps in the launch countdown that the crew have to step through in order to get us to launch today. And so we were saying, yes, inspiration, a big part of why NASA does what it does. We want to go together and we want to explore together to learn more about ourselves and here on Earth.
Yeah, humans, I think, naturally want to explore, and so going together, like Lisa said earlier, we're going to go farther and faster than we possibly can alone. And, you know, what a way to celebrate that today.
Yeah.
Going back to the moon in the first time in over half a century.
And we have that great shot there in our small box of the rocket on the pad. And at the very top there, our Artemis II crew. Right now, we know that the crew has begun the closeout crew has begun doing that cabin leak check. So they are currently pressurizing the cabin, and it sounded like it would take about 6 to 8 minutes for them to get to pressure, and then they have to hold that pressure for 5 minutes, right?
Yes, that's correct. Yeah, so there's quite a bit of volume. You know, we talked about it being a 6-person tent. I think it's 330 cubic feet. Don't quote me on that number, but you know, they have to, like we talked about, take that initial pressure, wait 5 minutes, and take the second pressure.
Yeah, and then it takes about 6 to 8 minutes again to depressurize the cabin. So this process will take a few minutes.
Ascent switch configuration complete.
OTC copies. Thank you.
And then after the cabin leak checks, then they will finally close the last abort system hatch. So again, chugging along in the countdown, really excited to, again, continue to hear the crew's voice inside Orion, stepping through all the procedures.
Yes, it's exciting to hear them making progress, right? It's all good news hearing the crew talk to the ground and working together to get to the launch.
And what I think is really cool is that this is the first time NASA is going to have astronauts in low Earth orbit, but also in deep space at the moon. So here's a message from some of the crew aboard the International Space Station right now.
Hello, Megan, and a big hello to everyone around the world counting down together to the launch of this historic flight test. If we weren't in microgravity, we would also be on the edge of our seats.
Here on the International Space Station, all of us are honored to have the chance to wish our fellow explorers Godspeed. Throughout human history, the moon has sparked our imagination, curiosity, and wonder. With our return to the moon, we're not only going to be learning about its history, the history of our solar system and of our planet, but also about our place in the cosmos.
We are so proud of the Artemis team and so excited for what you will see and learn on behalf of all of humanity during your trip around the moon. As we push the boundaries of exploration and expand our knowledge with scientific discovery, we advance our collective civilization together as one.
Test flights are crucial to the mission of exploration. We all learn in test flight schools that the more challenging the missions are, the more incremental the tests should be. This Artemis II mission is one more increment on the way to further exploration.
Thank you to the crew, our friends, for your dedication. And from the entire Expedition 74 crew, Thank you to all of the teams that had a hand in getting the Artemis II mission to where it is today.
Back to you, Megan, as the countdown continues.
Oh, I love that so much. I just love seeing them there. And again, you have to remember the International Space Station is an orbiting lab. We learn so much there, and we're going to learn so much more from Artemis II, because this isn't just a test flight. It's an opportunity to learn more about the moon, deep space, and how humans can live and work so far from home. So here are some of the science objectives that NASA hopes to accomplish with Artemis II.
Artemis II is our return of humans to the moon, flying around the moon on board Orion. But along with that, we're doing a lot of great science.
One of the exciting things about the Artemis missions to the moon is that science is actually a fundamental pillar of why we explore, why we're going, what we're doing in Artemis.
I think it's incredibly exciting that not only are we testing the vehicle, but we're testing science on board. Science where the astronauts are conducting experiments, science riding along with the astronauts. We have astronauts looking outside the window and really observing the lunar surface.
It will help us understand the deep space environment. It will help us understand how that environment affects our astronauts, our systems, and life in general.
So deep space is a challenge for us because you have to leave Earth's protective magnetic field. Here in low Earth orbit, the crew members are protected from some of the harmful radiation. Going to the moon, they'll no longer be protected, so they'll have a higher radiation exposure.
Much like Artemis I, we have so many radiation sensors and detectors that are inside the capsule so that we can fully understand and appreciate the radiation environment for protecting our astronauts. In my hand here, I'm holding a tissue chip model. This is the exact design that's going to be flying alongside the astronauts. We'll be collecting samples from each of the crew members, and we can make these organ chips out of the astronauts themselves. So every crew member will have their own avatar on board, and then upon return, we can evaluate that deep space radiation environment and what that compares to the astronaut themselves. Not only are they going to help change the course of medicine for the astronauts, but revolutionizing that on Earth as well.
We're looking at sleep, we're looking at team dynamics, we're looking at how you interact with the environment. We're also looking at the immune system, so what are the biomarkers? We're using saliva as a method to study hormones and different things in your body that may change during a mission like this. And then finally, how do we function after microgravity, being close to the moon, then returning to Earth.
Which will ultimately help us achieve our goal of getting humans to Mars.
And then on top of that, we have an opportunity to look at the moon from deep space on the far side for the first time in over 50 years.
Having human eyeballs and brains back around the moon is going to unlock a new generation of lunar science discovery. The human eyeball is capable of taking in so much data in just a split second. They'll be able to tackle impact history, volcanic history. They'll be able to look at how the albedo, or kind of the shade and hue of the moon and the color of the moon, can tell us something about how that terrain evolved over time. We're integrating science in ways that have never been integrated into human exploration before. We have a front room mission control flight controller position called the Science Officer. We have a brand new science back room where it's basically our brain trust of lunar scientists and geologists supporting the crews of the future. And Artemis II will allow us to really test how this works so that future missions are really set up for success.
We'll also be deploying some CubeSats. They're small shoebox-sized spacecraft of their own. They're each provided by another country, one of our partners. As they conduct their research, they'll complement what we are doing at the moon with Orion.
It is so incredibly exciting to be a part of this mission.
And it has been, really one of the privileges of a lifetime.
I can see the work I'm doing benefit crew members right now and benefit the crew members in the future. So it's incredibly exciting and it's very rewarding.
As this rocket launches humanity off of the Earth, we'll be setting the stage through our science to prepare humanity to leave Earth and explore the solar system.
And what we learn during this and future Artemis missions to the moon will eventually get us to Mars. Here's Jasmine Hopkins again, now with Nikki Fox, Associate Administrator of NASA's Science Mission Directorate.
Thanks so much, Megan. Yes, we're back on the balcony now, joined by Dr. Nikki Fox. Nikki, in this nearly 10-day mission, we are covering a lot of science from CubeSats to tissue chips. What are you most looking forward to learning?
Oh my goodness. I think for me, the most exciting thing is actually being able to interact with the crew while they are flying, doing this historic journey on the far side of the moon. They are going to be seeing pieces of the moon that no human eyes have seen before, which is really spectacular. It's going to be an interesting trajectory. Some of it is in darkness. Then at the terminator, so in darkness they'll be able to look for like impact flashes and things when micrometeorites pummel that poor moon. And then at the terminator they can see shadows and interesting things, which kind of gives you depth perception. And then of course in the sunlit, picking out everyone's favorite craters. Also, if we launch today or tomorrow, they will see a total solar eclipse from the Orion capsule. How cool is that?
That is very cool. We are thrilled for this Artemis II crew to be able to see the moon in a way that we've never seen before. What is so unique about that far side? Why are we going there?
I mean, honestly, it's just, it is unique. It's very different to the near side of the moon. The actual sort of terrain, the morphology, it's very, very different. And so it will be very exciting to see that as we're going past that.
Absolutely. And Nikki, you know, we are performing a lot of science at the moon this year, actually, not just Artemis II. Can you speak to the commercial lunar landers we're planning to send?
Yes, we are very, very proud of our commercial partners as they take our payloads for us to the lunar surface. And very excited. Next one up is Blue Origin's Blue Moon Mark 1 going. It's got some science on it. It's got the scalps that went on the Blue Ghost. So we'll be able to sort of look at that plume as it's coming down onto the lunar surface. And then also the laser